Welcome to this video. We're going to learn how to specify the direction of a two-dimensional vector. When we say direction, what we really mean is the angle that the vector points along. So imagine you're the captain of a pirate ship, and you have a map. The map shows where you're located and where the treasure is located. And you have to sail your ship from your current location, over to the treasure. Now you're a pirate captain, okay? And a pirate captain doesn't sail her own ship. She has an assistant to do that for her. So you have to go to your assistant and explain how to get to the buried treasure. You might be thinking, well, shouldn't I just show my assistant the map? Doesn't that make sense? Well, yes, normally the answer is yes. But your assistant is the kind of person who spills her coffee on herself in the morning and is kind of on her papers, and you really don't want to give her your only copy of the map. So you have to tell her how to get to the treasure in words. And you think, I have the perfect way. We studied this in physics. So here's what you tell your assistant. You say, "Arr, we must travel 1,400 meters, arr, along an angle of 25 degrees, arr." Now, are you a pirate or are you Scottish? I'm not sure. Gotta work on my accents. But that's what you tell your assistant. And here's what you're thinking. 1,400 meters along an angle of 25 degrees. How could that be clearer? But here's the thing. Your assistant says, okay, 1,400 meters along an angle of 25 degrees. And she goes to the wrong spot. So what do? Do you say, throw her over the plank, right? No, you're not that type of pirate captain. You're a benevolent and understanding pirate captain. So you say, gosh, I should have been clearer with my words. How do we specify this, or how do we distinguish this angle from this angle? What's the difference? How do we communicate that difference using words? Well, here's how. I'm going to teach you how. Let's take that original angle that we were trying to communicate. We're looking at a map, which means we're dealing with north, south, east, and west. So you imagine in your head, you overlay those cardinal directions on top of your vector. The first thing we need is a shell. Here's the general sentence structure we will use every time we specify the direction. Now I've already written in the distance, 1,400 meters, the magnitude. And then this part, everything that follows, is the direction. So we have 1,400 meters directed along an angle of, or directed at. The first is 25 degrees. That's the angle itself. So you type in 25, right? 25. 25 degrees. And next, we're going to skip this blank and come back to it. We're going to focus on this blank. The last blank is, you find this last blank by looking at what you've used to mark the angle. We are marking the angle from this line. Right? We are measuring our 25 degrees from this line to the vector. And this is east. So that last blank is east. And then in the middle blank, you say, okay, have we gone up? Have we gone up to get to this vector? Or have we gone down to get to the vector? We went up, but you can't say up when you look at the direction. You have to say we've gone to the north. So our direction is north in that middle blank. And on the whole, here's what we have. 1,400 meters directed at 25 degrees north of east, or north from east. So we're not going straight to the east, or we're not going due east, as they say. We're going north from east. Let's try it again with this, with the second vector that we saw. You imagine overlaying northeast, southwest. The first blank, 1,400 meters directed at, first is just the amount of degrees, 25 degrees. We're going to skip the second. Our reference line in this case is still east. we're using east to measure the angle. We're measuring that angle as 25 degrees down from east, so we're measuring it away from east. So then, finally, we look at whether we've moved up or down, whether we've gone north of east or south of east. We have gone south of east. So that is our basic process. Now we have to take it and see one other example, one other way that these directions could appear. Imagine we have a house, and above the house there's a bird. Now, don't ask me where this bird's wings are or how it's flying without wings. But we just want to say, okay, what's the bird's position? And we're going to use some spot over here as the origin. The bird, we would say, is 180 meters directed along this angle, which we need to specify. We're not looking at north, east, south, and west anymore. Up and down is simply up and down. Left and right is simply left and right. So there's our shell. And here are the directions we will use in this case. We have up, down. To the right we will call horizontal right, and to the left we will call horizontal left. We superimpose those directions over top of our picture. And then we use the same process. It's 180 meters directed at 55 degrees, so you put 55 here. And then, in the third blank, we are measuring from horizontal left. So we put horizontal left. In the middle blank, have we gone up from horizontal left or down to get to the vector? Well, to get to the vector, we start at horizontal left, and then we go up. We go up. So we put up from horizontal left. Or you could say up of horizontal left. So there's our process using different directions, up, down, horizontal right, horizontal left.